Hello, everyone. Uh, Hello, everyone. My team, consisting of Brian, Arya, and I, Sean, will be covering a report analysis failures within an underwater glider. We will examine how and why a part of the glider system have failed to improve the design and prevent similar failures in the future. Next slide, please. This section focuses on the failures in the key part of the underwater gliders called the buoyancy regulator, which helps the glider with adjusting its buoyancy. The study concerns two main problems. The first dilemma is the overall shape of the buoyancy cylinder, as its ovality can affect the sealing ability and surface scratching. The second dilemma centers on the bolt failures and issues on overloading the piston rod bolted onto the outer piston, which apply too much pressure in the bolt itself. Next slide, please. With the use of simulations, we can conclude that the cylinder failure is mainly due to shape defects and applied pressure, therefore stiffening the cylinder connections.
Okay. Could you go next? Lagi. 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 Okay, yeah. To avoid the failures discussed earlier, several key factors need to be addressed in the design and manufacturing process of these mechanical components. The first thing is material selection. Since the cylinders, the selecting materials that resist deformation and pressure will help maintain shape stability and improve sealing performance. Bolts should be made of high strength materials, such as high grade steel or advanced composites, to handle the high pressure loads and resist fatigue. Next is design specifications, which need to be improved. Increasing precision in manufacturing tolerances will reduce the risk of ovality and poor sealing for the cylinder. Optimizing the shape and surface finish can also minimize scratching and improve sealing. Simulations and tools like AutoCAD should be used to refine these design parameters. And bolted connections need reinforcement, possibly by increasing the size and strength of the bolts, or exploring fastening methods that distribute loads more evenly. Additionally, overpressure conditions should be addressed by incorporating safety margins into the design. Now, lastly, strict quality control during manufacturing is essential to ensure that the cylinder and bolts meet high standards. Advanced techniques should be used to achieve precise fabrication, and thorough stress and load analysis should be conducted to predict how different pressures affect performance. Regular maintenance and inspections will help catch wear or potential failures early, ensuring the components remain reliable and safe over time. By focusing on these areas, the likelihood of failure can be significantly reduced, resulting in safer and more durable mechanical systems. Next slide. In conclusion, addressing material selection, design improvements, and manufacturing precision is essential for preventing mechanical failures in components like cylinders and bolts. By implementing regular maintenance and inspection, we can ensure long-term reliability and safety in these systems. Next slide. Here are our references, and thank you. Udah sih.